R. R is a real number, right? The set of all real numbers. And this set has an order. When I say has an order, that simply means that given two real numbers, I can always compare them. Okay? So if I take 3 and 4, you can compare. If I take square root of 5 minus 7, you can compare those. So that's why we say that R is an ordering set. So an ordering set. So the notation usually we say that R, this is the order. Less is an ordering set. Because it will help us to draw line, to represent interval on a real, or when we take element from real numbers. But if I have C, we all know what is C, the set of complex number. This is not ordering. There is no order on this set. If you take two complex numbers, it might be difficult to compare them. Two complex numbers will be very difficult. It's impossible. Yeah, and also we have another set called H, the quaternion. Have you ever seen quaternion? Okay. Maybe because the representation is that the set of real number is a subset of the complex number, and the complex number is a subset of the quaternion. But maybe so on those complex and quaternion there is no order. You cannot compare. Therefore, you cannot represent interval. Because in order to start representing interval, you need to know what's the smallest number or what's the biggest, the maximum, the minimum. I mean, the bound, the upper bound and the lower bound. Okay? So, when you start thinking about interval already, you should figure out the order. There should be order. Right? What's the smallest value? Or the biggest value, and so on. Okay? So our interval here, we restrict ourselves on real numbers because we know for sure that the real numbers is order. There is order. Okay? Yeah? You follow me? Okay. So what do we call interval? Usually we denote interval as a capital I. So if I assume that if I take two arbitrary points x and y, let x and y, small x belong to x, and I take a c that belongs to this interval. What does it mean? Okay, so if I assume that actually my interval is formed by those points x and y. X and y are arbitrary points on the interval. Okay, so I can actually constitute a sub-interval from my interval I. Okay, so taking an arbitrary element in that interval, that simply means that I can write x less equal to the c, which is less equal to y. That's the meaning. In other words, what I'm saying is that actually my I actually is this set. This is my interval actually. So very soon now we understand when I do bracket like this, what does it mean. But you know that actually my interval here is bounded, has an upper bound and lower bound, and my bounds are x and y. Okay, and I say if I pick any arbitrary element in I, that's the meaning. But we need to be careful. We need to make a difference Yes. Okay. In our situation, actually, here it will be strictly less. So writing like this simply means that actually x is to be smaller than y. Okay? So in this situation, we have that x is less than y. So let's look at few intervals. The first one is called open interval. So as we said last time, we have actually different way of representing sex. Note that an interval is a set. That's the first thing you should know. Okay, an interval is a set. Okay, yeah. So this is my set. The set that I want to represent. Right? And the way that I'm representing, I'm taking all the real numbers such that we have this condition. Whatever you are representing the set, and then you have 2 point here, that's determined such that if you have 2 point here or this bar, it means such that if you have you open a bracket and then you have 2 points or bar like this, it means such that. Okay? So either I have to write this or like this. Okay? So now I'm taking a set of real numbers such that we have this. And this is a set. Okay? It is a set. Yes or no? Huh? And this set is, we can call it as interval. And it's called open interval on A, B. Why? Because A and B is not included inside our interval that we actually form. So we have strictly less than A, strictly less than B. A is greater than X, and X is strictly less than B. So that's how we constitute open interval. Open interval. Okay? So how to represent this? When you see something like this, it's obvious that A will be less than B. Because I was marking one of the scripts from the test. There was a question where they asked to solve the equation, and I think the answer will be to be -2 less equal to x less equal to 16, right? If I remember. You remember this? Yeah. I still see people writing this. Does it make sense? That's what I saw. A lot of people wrote this actually. That makes sense. How 16 will be less than? So you see now, the order is important. That's why whatever you do, we are on a real number, we know that there should be order. And you should respect the order when you are actually writing your interval. Okay? So A, here we assume that A is smaller than B. Okay? Yeah? So how to represent this interval? It should be a real line. A line. And then we have you can represent your A here, your B here. That's simply mean that A is less than B. A could be anything, B could be anything. Just an arbitrary. Yeah? A, anything. Okay? So, say this is an open interval. A and B are not included in that set that you are forming. It's an open interval, so A and B are not included. So how can we represent, how can we show that A and B are not included? We mark it by this symbol. This simply means that A and B are not included. And there is no order. So our interval actually here now is this. It is from here to here. That's our interval. Except A and B. Yeah? A and B are not included. So in this set, the set that we are constituting, A and B are not included. Okay? Yeah? Please. Now, an example, if I consider the set of real numbers such that um, 2 is less than, is simply less than x less than 7. If I ask you to represent this set, this is a set. Eh? Now, okay, let me draw you a question. What's the cardinality of this set? Yeah, who can tell me the cardinality of this set? Yeah? Yeah? Infinity. Why do you say infinity? Between 2 and 7. Yeah. Who disagree or who agree? You agree? Yeah, that's correct. Very good. Yeah. It's an infinite set. You cannot count the number of elements from 2 to 7. It's impossible. Because actually, it's a continuous interval. And you are picking the element from real numbers. But if I change, now it becomes finite. You understand that? It becomes discrete. If I do something like this now, it becomes discrete. It becomes finite. You can know the number of elements, which is 3, 4, 5, and 6. Yeah? But if I do something like this, I'm picking the element from a real number such that we have this becomes interval, and it is continuous. An interval has to be continuous. Okay? So, if I want to represent now, we have 2 and 7, right? 2 and 7 are not actually part of my interval. Okay? So let's say this is my interval. So, example, I'm considering the interval I1. So here, this is my interval here. And it is continuous. Do you know the reason why it is continuous? Because you can have infinite points. So we can have 2.1, 2.11111, 2.3, 2.2. So have infinite number here. Continuous. You see? So this is my I1. Yeah? Any questions? So, but you must be careful there. If I change, if I give an example, this one, x element of z such that 2 less than x less than 7. Now, the question I want to ask you is this an interval? Yeah. Who's laughing? Yeah, is it an interval? Is it an interval? Yeah. Is it an interval? It's an interval. Yeah, it's an interval. Yeah. Let's go now. It's an interval. Why you say yes? So pay attention. This is not an interval. Yeah, it's not, but it's a set. Yeah, yeah. Because an interval has to be continuous. That's very, very important. Yeah? Because here now, this is a set. This is a set that if you want to write the discrete element, I mean, if you can write you can start writing the elements, which is 3, 4, 5, 6. That's all. Yeah, those are the elements. It's not an interval. It's a set, but not an interval. Okay? But the first example is an interval, and at the same time a set. You see that? So a set can be an interval. But okay, any interval is first of all a set. You see the difference? Alright? So this IT here now, if you want to represent, it's not an interval, but you just you can write, you can do this as a 3, 4, 5, and 6. Alright? Okay, so we can have another example. So this is an open interval. So if I take another closed interval, this set x real numbers such that a less equal to x less equal to b. This is closed. And the notation here is a, b. We close. That's the notation. We close by a and b. So when you say closed interval, it simply means that actually a and b are included, are part of the interval. Okay, they are part of the interval, and yeah. So if you want to represent it, you represent by these points, a and b. So it is this continuous interval. Okay. So you have different forms, and I'm not so sure if I will go through all of those forms, but the most important is that you should know the situation where you are. And so we have also half open interval. Half open interval. So the set of real numbers such that a is less than x, less equal to b. So you see now that a is not included here, it's simply less, and then we have less equal. So if you want to write it in our way of writing interval now, you open the brackets here on a. So that simply means that a is not part of the interval, but the upper bound b is included. So we close it here. Okay? Yeah? Remember that if you are included the number, this is how you represent it. If you are removing it, this is how you should represent it. So the same way, I can do the other half of interval like this. So here now I need to close here and then open it from here. Okay? So you see. Yeah. Here. And we have also what we call open array. Open array. So when we have x, a real number, such that a is less than x, Here now we only have one inequality. One inequality. We consider the set of real numbers such that a is simply less than x. So we have our a here. So our x should be this side. So we are considering all the real numbers that are simply less than a. So it's called an array. Yeah.
Is there a notation like the brackets for the array?
The notation like this, yeah? Yes, the notation is so it's minus infinity. Okay. I think it's yes, you write the minus infinity. Okay? So you see all the real numbers that are less than a. So that's simply that you start from minus infinity. Okay, and here if you are representing the line, this is plus infinity. So all the real number less than a. So it is starting from minus infinity. So whenever you are writing minus infinity, make sure that you open this side. And so we are considering all those numbers that are still less than a, and a is not included. Open it here. Okay? And suppose now that we are considering all the set of real numbers that such that a is less than equal. If it is less than equal here now, you need to close it here. Okay? Yeah? Okay. Suppose now that we are considering a set of real numbers such that s is little less than b. In this situation, it will be our b if I'm here. Okay? And I want x to be let me do like this, greater than b. Okay? So that's something that I am here. So my interval should be from b to infinity. Okay? And it should be open interval. Open interval from b to plus infinity. Yeah? Here, why the infinity is included. Okay, good.
There is mistake.
Am I making a mistake here or?
Yes, there is a mistake. Should be greater, I think.
I think I made a mistake.
Yeah,
Okay.
greater.
Yeah, sorry. Making a mistake, yeah. All right. Yeah. Apologize. If I do like this, so we actually considering the set of real numbers such that x is simply less than a. A is simply less than a. That's something that my x could be anything from here. Anything from here. Who is speaking? Okay. So when you want to represent the line, actually, you have for sure the minus infinity is from this side, and then plus infinity is this side. Actually, the set of real numbers, you can represent it like this: minus infinity plus infinity. Yeah, this is the representation of the set of real numbers. Okay? Minus infinity plus infinity. You don't know what is in minus infinity. You don't know what is in plus infinity. You don't know. Okay? Now, if you are considering the set of real numbers such that x is 50 less, then you should be on the other side. Because x is our upper bound, I can say maybe maximum, is a. So since our upper bound, the maximum is a, this statement x less than A, it should be from this side. So therefore, if I want to write it as interval now, it should be minus infinity to A. Yeah? Okay, so this now is equal to minus infinity to A. And then I open the bracket. Yeah? So, but suppose that actually I have x less equal to A, then I should close it from here. Okay. Yeah? It's much clearer. Okay, now looking at this, we have the set of real numbers such that x is greater than b, greater than b, greater than b. If you want to represent it, it should be any number from b up to plus infinity greater. All the numbers that are from this side. So if you want to represent it, it should be from b to plus infinity. Okay? Yeah? And if maybe an example, you have greater or equal to b, then you close it from here, from this side. Yeah? Yeah. The plus, yes, yes. The minus and plus. Plus infinity. Plus. Yes, this plus. So that we know that you refer to plus infinity. I know in some books they don't, sometimes they don't write plus and minus, they just write infinity. But actually in the lecture notes, we want to emphasize that you should write the plus and minus so that we know actually that you were talking about minus infinity and plus infinity. Yeah. Okay, please practice by writing the plus and minus. Because for sure, if you write like this, for those who are advanced, yeah, we know actually that when we write it like this, we know you need plus infinity. Because the way that you are writing the interval simply means that B here is our lower bound. Yeah, if you write it like this, that simply means that B is our lower bound, the minimum. So if you start from the minimum, we know that you should be covering from minimum to plus infinity. Yeah. We know, but yeah. I think the lecture notes want us to write plus. Please write plus. But even here now, this simply means that actually A is our upper bound. Whenever you have an upper bound, then you should have a lot of numbers that are less than the upper bound. So therefore, it is coming from minus infinity. Right? The minus. Okay? Yeah. Any questions? Stephen. In a movie like this, you're sleeping. Monday. Yeah? Why you not to school now? I just explained to you now that's why you don't. But yeah. No, I think in as I said, in a lot of books, they don't yeah, but okay. If I do like this, how will you feel if I do like this now? What does it mean? The plus here, and I leave the minus. But for give me like this. Okay, yeah. Sorry? What do you mean numbers? Yeah. Okay. When you are writing interval, let's agree. Put plus minus. Whenever it is minus, just write the minus. Whenever it is plus, write it. Huh? Okay? Yes, just write it. Okay, write it. Now, here, suppose I have this interval. Let me modify a bit this interval. S. Yeah. Okay. So what is actually, if I want to write the discrete form of this interval, this set, not interval, this set. Yeah, who was talking? Yeah, yeah. What are the elements? You know. Oh, we're talking. Yeah. Is this the interval? Or is the interval? Look at it very well. Look at it very well. How to know that it is an interval? Let me explain. If you take your set, if you take your set, take an arbitrary 2 points inside that set. There should exist an infinite number of points linking those 2 points. Period. That's the meaning of interval. Do you understand my statement? You don't understand. I said for a set to be an interval, when you have your set, you pick 2 random points from this set. If you pick 2 random points, there should be infinite number of points that link those 2 points. Let me show you what I mean. What do I mean? Okay. This is my interval. This is an arbitrary interval. Now let me pick 2 random points from this interval, which I denote x and y. X and y are 2 random points. Okay? Yeah? X and y are 2 random points. So if I pick 2 random points from this interval, there should be an infinite point that led me x to y. So from x to y, there should be infinite point that led me to those 2 points. Infinite. So now look at the second example. If you take 8, you take 9 and 10. 9 and 10 are 2 points, right? Between 9 and 10, do I have an infinite number of points? So it's not an interval. Do you understand now? Yeah. Any number that are inside this interval, any 2 numbers. That's what we are saying now. Yeah. Yeah. Because if you start speaking from integers or natural integers, it's discrete. You cannot, if actually you take 2 natural numbers, you cannot find infinite points between 2 natural numbers. You cannot. I hope you are getting the point. So, for instance, from the first example, if you take 3 and 4, 3 and 4, From 2 and 4, we have actually infinite number here. You cannot count. They are plenty. Infinite number. Eh? But in our setting here, if you pick 8 and 9, 8 and 9, you cannot find that. Do you understand now? Okay? Okay, so now if I want to write man is 8, 9, 10. Okay? That's the way to write it. Yeah, we just 2, 3. I think it's N dot or maybe dot. N dot, yeah. Yeah, infinite numbers of points. You cannot have points, every number of points. Between what? No, just to the order, normal order. Yeah. 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 You cannot have anything, just use points. Yeah. No, 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 no. Okay, there's a bit of confusion, eh? For a second. Okay, I'm going to look. Do you notice this fact? Yeah? Okay. Here, all the x has to be real numbers. Eh? So since they are real numbers, I drew my interval already, 2 to 7. Okay? Now, if I take, I'm given a strategy to claim that a set is an interval. So when you pick any random point from a set, and you find out that there is an infinite point that let those 2 points that you pick, then this is for sure an interval. And I'm giving an example. So when you take 3 and 4, actually you have an infinite number of points from 3 to 4. If you want to go from 3 to 4, you have infinite points. Yeah? No. Here now is this integers. Look, the set of integers. You have 7, 8, 9, 10. Integers. Why? What is an integer? Oh, okay. You are changing the setting now. Oh, okay. You are dealing with the first example. Okay. You should tell me. Okay, you are still here on the first example. You have 8, 9 here. Yes, there's infinite numbers. Yes. Oh my goodness. Actually, you are still busy on the first example. You are still busy on the first example. Yes. But actually, no, you cannot do that. Because 8 and 9 are not an interval. 8 and 9 is not, I said, if you want, listen to me carefully. And you listen. If you want to claim that an interval, a set is an interval, let's consider this. The set I. You don't know what is I, but you want to check whether I is a set. Okay? First of all, it is a set. But you want to figure out whether this set is an interval or not. Okay? You pick 2 points from I. 2 random points. Those those 2 points has to be in I. Don't sleep, eh? Those 2 points has to be in I. A and B. Or I will pick X and Y. Now, when you pick 2 points, X and Y, that are inside this I, you need to check whether there is an infinite point that led X to Y. If there is, then it is an interval. If there is no infinite point, then it is not an interval. Does it make sense? Huh? You sure? Okay. Yeah. Okay. So, yeah.
What's the very last one?
In that sense,
Do you need three values or?
you can put many as you want. Many as you want. Yeah. You can put maybe 4, 5. Yeah. There's no specific rule that tells us to write that. You can just put 2 or 3 or 4, 5. But already 3 is enough. Okay. Yeah. Yeah, these are numbers. If X was rational numbers. Okay. Okay, good. That's good. Okay. Yeah. Yeah. That's what you mean. Eh? No rational numbers. Oh. How do you write yes, Q. Okay. Yeah. So now, yeah. You want to figure out whether it's yeah. It's an interval. Because first of all, the set of decimal numbers is a subset of rational numbers. This is the way to see it. You have the natural integers, you have the decimal numbers, you have the rational, you have the real numbers. Okay? So this is the inclusion. Yeah? No, this is irrational. This is irrational. We're talking about irrational. Yeah. No. Okay. So between 2 and 7, yeah, you can have infinite number of decimal numbers between that. But decimal, if you take 2.1 and 2.1 is a rational number, right? 2.5 is a rational number. Yes or no? 2.5 is a rational number, yes or no? Oh, you need to think about that. 2.1, 2.5 is the rational number. This is the rational number, right? This is the rational number, yes? Now, I said, I still go through my statement again. If you pick 2 rational numbers now that are between these interval 2.1 and 2.5, you can have infinite points between 2.1 and 2.5.
signage